3, 4 gets associated with 4. Okay, so actually the set A intersection with B cross A is the set of ordered pairs 3, 2, 3, 3, 3, 4, 4, 2, okay, 4, 3, and finally 4, 4. Okay, its cardinality is 1, 2, 3, 4, 5, 6. Okay, actually let's write that down. The cardinality of A intersection with B cross A, its cardinality is equal to how many elements there is in its collection or within the set. 1, 2, 3, 4, 5, 6. It's equal to 6. Okay, let's do something else. Let's maybe do a power set. Okay, so let's just write this down. We want to do a power set. Okay, and let's calculate what the power set of, let's say, what is the power set of, let's say the set is B without A. Okay, this is the same as saying, this is equivalent from a notation perspective of what's the power set of B minus A. Well, before we can calculate any power set, we need to calculate what this particular B minus A is. B without A. Okay, let's just keep in mind, well, B without A is all the values in B that don't include any of the values of A. Okay, so this is going to be, well, B is the values 3, 4, 5, and 6, and what we need to take out of there are the values in A, which are the values 2, 3, and 4. So B without A is, we take out 2, 3, and 4. 2, so, well, 2 ain't there to take out, so we can't take it out. 3 we take out, and we take 4 out. So what's left behind are the values 5 and 6. Okay, and the power set of B minus A is defined to be all possible subsets. Okay, so the smallest subset that we could have is the empty set, so let's put that in the power set. The next smallest subset are the singletons, so we could have a 5, we could have a 6, and then the next subset, the largest possible subset that we could have of any set is itself. So what we have here is we have 5 and 6, and that's our power set. Okay, so there's another example of what we could do. So we've done a few things here. We've done intersections, we've done unions, we've done cross products, we had a look at the cardinality operator, which is how many things there is in our sets. We've calculated the power sets. Actually, we've done set difference as well. Okay, let's have a look at another example. This example probably being a small little bit more complicated. Okay, so let's say we have a set. So consider the set. Let's say the set is X. That's equal to the set of values. Okay, there's a set of let's say there's a set of X's such that X is an element of the integers. Okay. And also, let's say, for argument's sake, that X is bigger than or equal to 1 and less than or equal to 700. Okay, this actual example I've sort of taken from Hunter's text, Essentials of Discrete Mathematics. Yeah, okay. And the question that Hunter has asked is this: how many integers? Okay, how many integers in the set X, okay, are divisible by, let's say, 2 or 7. Okay, question mark. And that's what Hunter asked. Here's a set here. How many integers in that set are divisible by 2 or 7? Okay. Now this is defined in set builder notation form. In roster form, now it's going to be an infinite list. Okay, in roster form, this set X is the set of values. Their X's, the members have to be integers. Okay, they have to be bigger than 1 or equal to 1 and less than or equal to 700. So we have 1, 2, 3, 4, 5, and all the way through to 698, 699. and 700. So we have a very large set. Let's think about it. This set contains all the numbers from 1, inclusive of 1, and all the successors to 1, okay, and their successors all the way through to 700. So actually, the cardinality of this set, the cardinality of X, is equal to 700. There's 700 members, yeah, okay, and they're clearly listed here, okay. So let's think about this here for a moment. This set is made up of odd numbers and even numbers, okay? So clearly there must be half them must be odd. Okay, so the odd numbers. So let's say odd. Okay, odd of x. Okay, of the set x is the values 1, 3, 5, and all the way through to 6, 9, 9. And even of x. Okay, are the values 2, 4, 6, all the way through to 700. Okay. And actually, there should be the same amount, okay? In this case here, from 1 to 700, yeah, okay? Well, let's think about it. Let's say, what about from 1 to 4? Okay? How many odd numbers are there and how many even numbers? So from 1 to 4, inclusive of both bounds, there's 1, 2, 3, 4. And you can see that we have 2 odds, and we have 2 evens, okay? What about when we go from 1 to 5? Okay, well, 1 to 5, we've got 1, 2, 3, 4, 5. In this case, there's 1, 2, 3 odds and 2 evens, so they're not the same, yet it's a different number. What about when we go from 1 to 6? Well, when we go from 1 to 6, you can see 1, 2, 3, 4, 5, 6. We have 1, 2, 3 odds, and we've got, oh, there we go, we've got 3 evens. You can probably see a pattern here. When we start off with an odd number, okay, and we end with an even number, okay, here's the odd numbers, and when we end up with an even number, okay, there's the same number of odds and evens, yeah, in that particular list, okay. And here's in our situation here, our list is going, or our set is going from an odd number through to an even number. There's 700 of them. There needs to be the same number of odds as even. So in this case here, we're going to have, well, there's 350 numbers divisible by 2. Okay. What about the numbers divisible by